In this video, we're going to find the arc length of 5x squared from 0 to 3, and we're going to use the fact that secant cubed theta, the integral of it, is 1/2 secant theta tangent theta plus ln of secant theta plus tangent theta. I actually have another video where I show how to do that. I didn't want to use time in this video for that particular thing. Now, the biggest thing with arc length is to know the formula. So it's the integral from a to b of 1 plus prime of x squared dx. Two most common things that I see mistakes on: either the derivative's not used here, the original function is, or not squared. So our f prime of x is actually pretty simple. It's just 10x. So we go from a to b, square root of 1 plus 10x squared dx. Now, and we can even know our a and b because it's going to go from 0 to 3. Let's just go ahead and put those in. So with technology, we could actually find the arc length right now, and in certain cases that's all we need to do. Let's talk about how we would do this one by hand. So we're going to need a trig sub, and specifically I'm going to let the 10x equal tangent x, and then 10 dx equals secant squared x dx. Now, what's going to happen here is when I go to plug these in, first off, I'm going to need a 10 for the dx. I'm going to put a 10 in there, which means I'm going to end up with a 1/10 out here. So I have a 1/10, 0 to 3. We might go ahead and change these. Actually, we probably shouldn't use x here. Let's change those maybe to thetas. We'll probably change our limits. Well, let's leave them for right now and see what happens. And I've got square root of 1 plus tangent squared theta, secant squared theta, d theta. 1 plus tangent squared is secant squared. Square root of that is secant. That's where the secant cubed is going to come from. So we have 1/10 secant cubed theta d theta. And these are x values here. So it may be helpful to go ahead and turn them into theta values so we don't have to worry about changing them later. So our lower value is 0. So plugging 0 in for x is just going to give us 0 equals tangent of theta. That gives us theta equals 0. So our lower limit's still 0. The upper one's going to get a little bit weird because we're going to have 30 up here. So 30 equals tangent of theta. That means theta equals the arctan of 30. And we will just leave it like that. Alright, now we're going to use our note from above to help us finish this thing off. This is done with integration by parts. Again, I do it in another video. It does take a little while, so I'm not going to do it here. So we have 1/10, 0 up to the arctan of 30, so we don't mess with decimals for right now. Except we don't need that anymore, do we? We have 1/10, we actually know the antiderivative, times 1/2 secant theta tangent theta plus ln of secant theta plus tangent theta. We don't need the plus c because we're dealing with a definite integral, and we are going from 0 to arctan of 30. So, got a little bit of work to do here, but let's see how this all plays out. So 1/20th, we're going to have the secant of the arctan of 30. Now here's one that's going to work out nice. Tangent of arctangent of 30 is just 30, so times 30, plus the natural log of the secant of the arctangent of 30 plus, again, arctangent of tangent of 30 is 30. Now we do need the second half of this, so let's do an extra set of parentheses just to keep these separate right there. Minus, now we're going to be plugging in 0, and we'll do the whole thing times the 1/20th, so I won't write that again. Tangent of 0 is 0, so that works out nice. Secant of 0, well, secant is 1 over cosine. Cosine of 0 is 1. So what's going to happen here is this will be 1 times 0, which is 0. This is going to be 1 plus 0, which is 1. Natural log of that is 0. So all of that part goes away. So really, the only thing we need is what the secant of the arctangent of 30 is, and we'll have this thing looking nicer. Well, remember where the arctangent of 30 came from. It came from the fact that tangent of theta equals 30. So over here off to the side, what I like to do is I like to set up a right triangle, call one of my angles theta. We can think of that as 30 over 1, so tangent is opposite over adjacent. And now we can find the hypotenuse, which is going to be the square root of 30 squared plus 1 squared. So the square root of 901. Now secant of that, because now remember, basically this here was theta. When we go to take the secant of that, well, secant is 1 over cosine. Cosine is adjacent over hypotenuse, so we have a hypotenuse over adjacent. So square root of 901 over 1. So putting this all together, we get 1/20th times, this first one here is going to be 30 times the square root of 901 plus the natural log of the absolute value. We don't need the absolute value because both are positive. Square root of 901 plus 30. And there we go, is our nice exact answer. If we need a decimal approximation, we can put that into a calculator.